So listen, this is our last thing. This is the last thing I'm going to ask of you the whole year. Monday will just be, if anyone wasn't here or if any of you have any excuse me, Jane. Monday will be for if anybody isn't here today, they'll be doing this. Or if you have any last minute questions, I went too fast on a part, you need to write it. I will upload this, of course, to Canvas, and I made a video of it. I'm making it right now. This is it. So I just need you guys to stay with me for this last class period. Monday, like I said, I already told you what you're doing. Tuesday, of course, you have the exam. After that, we're not doing anything, okay? So this is really my last time I need your full attention. And because I have a lot, we've learned a lot. So we have a lot to write on here. But this is, I really think, going to be helpful to you to have and just to be looking at when you have time, especially right before the test, one piece of paper, not a whole binder, all of that, okay? So as a reminder, it's on Tuesday. And I told you guys to meet 7:15 in the gym lobby. Miss Frazier's email said to meet outside of J-Wing, if you read it, which is the same area, right? Right outside the gym, and J-Wing is the first. So in that area, I'll be there, so you'll look for my friendly face. Make sure your laptop is charged. Charge it, guys, and bring it. And bring your charging cord just in case. If you lost your cord, find a friend or somebody that's not testing that day and borrow it from them. If you checked out a calculator, Chase, Zach, Jocelyn, Dan T, Remy, Haley, Juan, and Evan, make sure you have it charged and bring it that day. Okay? Do not forget that. And you can write with blue or black ink. I gave you guys all a blue pen. You can use any blue pen. I don't care if it's not mine. No other colors. You can use pencil, not mechanical. Okay, no other colors, no highlighters, no whiteouts, no rulers. That's what you're allowed to have. And know your College Board login. This is why we did that last week, where I had every single one of you log into Blue Book. Make sure you knew your College Board login. You know, the holdup, you guys want to start at 8, which is when we start, and there's directions being read before that. We want to start at 8, be done as close to 11 as possible. If people are showing up late, don't have the proper stuff, it's going to slow the whole process down. You're a big group. There's 129 of you, give or take a few that have extra time in a different room. So let's just say 120 of you in the gym at one time. It's every single one of my students. So it's a big group to get settled. The more of you that are ready to go, on time, prepared, the smoother it's going to go. You're very lucky. You have very nice proctors. Miss Leja, Miss Anderson, and I think it's Mr. Clemmer are all so they're nice people. They'll be friendly and all that stuff, not proctors that yell and scream at you. So that's good, all right? But just be ready. And if you want, I'm not telling you have to write it here. Some of you don't feel comfortable writing that stuff down. But if you are worried that you're going to forget it on the day of, write it down, look at it right before you go. Because remember, it doesn't save in Blue Book. You have to type it in each time. And you don't want to be like, oh, I need to go find my phone and figure out my login. The proctors will not have the logins for you. You have to know your College Board login, okay? All right, so as we go through, guys, write what you want. You can write the same things I write. If you don't want to waste time writing it down, time or space, don't, because maybe it's something you know. I'm just giving you everything I can think of, and you guys do with it what you will. All right, first thing is don't write it. We've talked about that the whole time. Refer to graphs by name or functions by name, anything by name, like h of x, f of x, or h. You don't have to put the x part. You can, shortcut as graph of f or h, or the rate of change of f or h. Don't say it in an FRQ. Let's use concave up, not concave up like that, or AROC. Remember, we abbreviate in this class all the time, but your AP exam is like your final performance. You want to put your best foot forward. We stop using abbreviations and things like that. We don't say it. We're making sure that the person grading knows exactly what we are saying. You know what I know. We have our own abbreviations and things we say in here, but on the AP exam, you just want to make sure you put your very best foot forward. We talked about don't circle answers. You can. It's not against the rules, and I'm going to repeat myself on some of these things, even though I've talked about a lot of these things in class. Some days people are absent, not listening or testing or whatever. We talked about don't circle answers because we are trained when we learn how to grade the FRQ in the summer. We get trained on it. And one of the things they tell us is find the answer in that, question 2A1 or whatever, in that box. I'm looking for the right answer. If I see it in there, I can give you the point. If you circle something that is telling the grader, don't worry about it. I know that this is the answer. This is where you look. And that's all we're allowed to grade is what's circled. So by circling something, you're not going to get it wrong necessarily, but you could be giving away a point by saying the wrong answer, okay, like going too far or something. So just make it a rule. Don't circle. Round to 3 decimal places correctly. I still have students not rounding correctly. You know who you are if that's you. If you are still making mistakes when you round, what a shame to get a question wrong when you know how to do all this complicated stuff with a calculator or with the equations on paper, whatever, and then you round it wrong and you lose the point. So if you know this is you, find some time with me. You don't even have to talk to me. You can Google it. Google proper rounding rules and watch a video on it or practice or something. That's not something you want to get wrong. FRQ 3 Part C has a multiple choice question, A, B, C, D, and we've been circling it. On the actual exam, you'll just write the letter. It'll be this whole big space. You're going to write A, B, C, or D, whichever answer it is. And we had this problem last year, and we wouldn't know, is that an A or a D, okay? So to clear up that issue, use capital letters. If you use a capital A, B, C, D, there's no way we're going to confuse it, okay? If a grader does not know what letter you're writing, then you're going to get it wrong. So that's not what we want. We've talked a lot about time management tips. If you're guessing, so you're in the multiple choice and you get to a question and you're not sure and you're wasting a little bit too much time, pick an answer, pick a letter, pick any letter, whatever letter you're choosing, and then flag. Remember, what if you run out of time and you left something blank? Don't leave a question blank when you move past it. Pick something, flag it, so if you do have time, you can go back to it and spend time on it. But at least you have a 25% chance of getting it right versus a 0% chance if you left it blank. If you have time after the first multiple choice, remember that's 80 minutes long to do 28 questions. Oftentimes we see students just sitting there with nothing to do. You cannot move on. You have to let the 80 minutes run out on your screen. So after the very first multiple choice, 28 questions, no calculator, you're sitting there. Remember, we've talked about it many times. You have that scrap paper in front of you that you get to keep the entire time. That would be a great time to leash some of that stuff right on your scrap paper, maybe quadrant 1 coordinates. All students take calculus, formula, whatever. That way it's just there for you when you get to some of the FRQs later and you don't have to worry about it. Completely optional. All right. And then don't forget, I'm not going to write out a whole thing here, but FRQ 3 and 4, they're harder than 1 and 2. They take more time. Don't quit on 3 and 4. Find something you can answer. And for sure, FRQ 3 Part C. I'm just going to write number 3 Part C. That's about 2 points where you're just looking at a little section of a graph and you're just saying, is it positive, negative, increasing, or decreasing, and then writing a sentence about rate of change in concavity. You don't even have to read the word problem probably to get those 2 points right, okay? So if you're super unsure about FRQ 3, don't skip the whole 3. On FRQ 3 Part C, everyone should be able to do, okay? And then we talked about FRQ 4, find something that you know how to do. All right, if you're putting equations into like you're given a function, you use the y equals. We all know this, I just wanted to write it down. Right, so you go to y equals if you have an equation, and if you have a table of values or ordered pairs, we go to stat and then enter. Or you could go to decimals. Now, this next one is something we haven't talked about all year because it very, very rarely happens. It would make no sense for me to talk about this throughout the year because it's like 1 in 100 times it ever happens. And since it never happens, you won't remember it. But now I'm going to tell you what to do if you go to stat, enter, and your L1 is missing. I've seen it happen. Like I said, it's very rare, but there will be a time where L1 will be missing, and I have no idea why that happens. Clearing your RAM does not fix the problem, but there's a very, very easy fix. And I always worry that that's going to happen to you because there's so many problems where you have to use your L1 and L2. I mean, now I guess you could use Desmos if you know how to use it, but how to fix it here is super, super easy. In that same menu of stat, we normally hit enter to put the L1 and L2 in. Number 5 is a setup editor. If you just hit 5, enter, it will put L1 back. I don't know why it doesn't have it there and why that works, but that's what you're going to do. So I'm just going to put stat, number 5, enter. That fixes it. I mean, it probably won't happen, but if it helps 1 or 2 of you, great. If you don't know something I'm talking about, if you're like, wait a second, what is she talking about? A custom regression in Desmos? Because you missed that day, or you didn't understand it when I went over, or you weren't listening, write yourself a note. Ask her, about it later, or ask somebody. But if you get a regression, remember, regression is a model. It's when we use our stat enter, and we get, quad reg, X reg, all those. If you get a regression where you have a transformation, you can't use your calculator. Our graphing calculators are limited to only the parent function, no left, right, any of that stuff. So if that happens, that's when you have to use Desmos. And I've shown you a couple of times, but if that's something that you're not sure about, mark it down that you need to talk to me about it at some time before Tuesday, or ask somebody else about it, or explore it on Desmos, something, okay, so you know what to do. My students last year, they did have a transformation in their thing, okay, so it could happen, right? FRQ1 Part C on mock number 2, the one we did just this week, had a different question for Part C, which was definition of an inverse, or if it's not an inverse. And I said the words are really, really, really specific. Let's practice them. This is your script. You're performing. Come on, guys. I know you're writing a note back and forth, and it's really hilarious, but this is really important stuff. So if your inverse is not a function, so if it is, if you flip your x's and y's and that is no repeat x values, that means you have an inverse function. You would say this: each output value maps from a unique input value. Yep, memorization. I want you to spit those words right out. Each output value maps from a unique input value. If it's not a function, which is the type we had in our FRQ the other day, you say the same exact thing, but does not map. And then the rest of the words are the same. And you must give, do you think that was someone knocking?
Yeah.
I'll double check. And you have to give an example. So again, if you want to look at mock numbers. Sorry, what? Here?
Yeah.
I said ask if you, like, write yourself a note to ask about it if you don't know what I'm talking about. This is in the FRQ, your handwriting. Yeah. There isn't an example. Because you're saying there's no repeats. But if it's not, then you're saying, like, for example, these two inputs have the same, whatever it is. And for an example of this, FRQ1 from mock number 2, the one we did this week. And guys, you might be like, what is she talking about? This is like, she does this all day. I have 6 other classes. Remember, in Canvas, I try to be very, very, explain everything. In all the practice we've done for this AP exam, I've labeled very, very clearly. We did R1 to R7. It was like a little packet before the mock exam. Then we had mock 1, and I was like, multiple choice, No calculator, mock number 1. Multiple choice calculator, mock number 1. And then FRQ 1, 2, 3, 4 for mock 1. And I did the same thing for mock 2. And there's videos of everything, okay? So when I say that, I know you don't know that off the top of your head. I'm just telling you where you can find it. All right, correct limit notation. You know, I graded FRQ 1 last year where you will definitely have to do this, and so many students got it wrong because they didn't have proper notation. We always put LIM, and then this will be given to you, which is the name of the function, right? F of x, h of x, it's going to change from problem to problem. The limit of f of x, g of x, h of x, whichever problem, whatever we're talking about in that particular problem. Then you'll always have x approaches something that will also be given, right? Infinity or negative infinity or 0 as x approaches or x decreases without bound, right? That's given to you. You put that there. And then equals, and then you would put your answer right there. Okay? So just remember how to do proper limit notation. Polynomials, lines, quadratics, cubics, x to the 4th, x to the 5th, just a plain old polynomial. Let's just talk about that. The leading term is all we really care about typically. Where n is your degree and a is your leading coefficient. Tells us a lot of things. The degree tells us our number of solutions, right? Degree, like a linear equation gets 1 solution. Quadratic has 2, a cubic has 3, and so on. And it gives us our end behavior. So I'm going to review end behavior for you real quick here. Again, if you're good with end behavior, don't write it down. End behavior. If you have an even number degree, so if your degree is 2, 4, 6, whatever, you can either go up, up, or down, down, right? Evens go in the same direction. How do you tell? Up, up is if your A is positive. Down, down is if your A is negative. Like a parabola, x a second. And then an odd number degree. Remember, odd, opposite, like 1, 3, 5. So you can either have down, up, or up, down. That's opposite. And this is where I see the most mistakes. Remember, odd number degree, we think of like a line. And if it's down, up, that's a positive slope. That's when A is positive. When we go down first, that's a positive A. Up first would be like a negative slope. So that's a negative A. You guys should appreciate my jokes. There are 3 kinds of people in this world, those who are good at math and those who aren't. Thank you, May. You're my new fave. It's on your paper, too. It's like I can't see it. You should laugh. Huh? You know what else? You know what else I found as a math teacher? This is so funny. Like 3 out of 2 people don't understand fractions either. Yeah. May gets me. 3 out of 2. Yeah. I know. It's okay. It's okay. I know. Okay. Guys, this is just a bunch of formulas I'm going to throw on here. Change in y over change in x, right? Slope or AROC. Do you need to write it? That's up to you. You want to write it, that's up to you. There's a bunch of trig formulas we should know. Tan of theta is y over x or sine over cosine. Cotan is x over y or cosine over sine. And I'm leaving the variable off for time's sake. Those reciprocals, remember the friends? Sine is 1, I should be putting these x's on here. Don't be me. There should be a variable on these. I'm just being kind of lazy, sorry. Theta, x, whatever. And then cosine is 1 over secant. Remember the friends, who goes with who? So if cosine equals 1 over secant, then secant equals 1 over sine. You could flip one to get the other, okay? Those come up a lot. There's also this formula, sine 2x. That's our double angle formula for sine. We've seen it so many times in this class where you would expand it to look like that. Pythagorean identity, sine squared x plus cosine squared x equals what? 1. I'm going to put sum and difference formulas right here, but I'm not going to write them in right now. At the end, I'll put them up. They're on your formula sheet, so I'm not going to take the time right now, but leave a space for it if you think that's something you want to write. And at the end, when I'm done, I'm not going to write it 6 times today. It's that box. One more I want to put in here is the residual formula. Is actual minus predicted. How do you remember that order? It's alphabetical plus AP, this AP class. Remember, this is actual, is like the data. That's real life. The scientists give us how many white-tailed deer survived from this year to this year. Predicted is the regression we put in our calculator, and we can use the table of values there, the graph, or whatever. So actual is real life data. Predicted is our mathy stuff that we do to it. Okay, let's flip the paper over. Rational functions, we see a lot with these lately on these mock exams, and we haven't done them since Unit 1. So let's remember, rational functions are when you have a polynomial on top and a polynomial on the bottom. And when you have to graph these, you won't actually have to graph one yourself, like in an FRQ, but you can see it in a multiple choice. You have to factor everything. And then you'll identify vertical asymptotes, poles, and zeros. And then we'll also talk about horizontal asymptotes. So you factor everything. We had a great question in our most recent mock number 2 multiple choice, where it was this big, complicated rational function, but it was all factored for us. You had to cancel and all that stuff, and then you had to decide how many VAs and poles. So remember, VAs are what are left in denominator. Poles cancel in the denominator, and zeros are left in the numerator. And I put it in this order, in order of hierarchy. Remember this picture, vertical asymptotes beat the holes, x-intercept's always the loser. So if you're trying to decide if something's a VA or a hole, because you might have canceled and one is left, VA will always beat the hole will always beat the zero, okay? Zeros are also called x-intercepts. I think we know that, but I guess that helps. Okay, so for horizontal asymptotes, we look at the degree of the numerator and the degree of the denominator. If n is less than d, then our HA would be y equals 0. If n equals d, you have to make a fraction out of the leading coefficients, the a and the b. And if n is greater than d, we have none, and you must check for a slant asymptote. You have a slant asymptote if when you subtract those two, you get a 1. We had a multiple choice question on Mock 1 that asked about this, and in Mock 2, it didn't say anything about a slant asymptote. It was either it does or it doesn't have an HA. So just read the choices and see which one makes more sense. Exponential functions and logs, really important. That was what Unit 2 was. The whole unit was exponentials and logs. So it's not surprising we see a lot of questions that have to do with exponential functions and logs. Exponential functions are in this form, okay? A is your y-intercept. And I'm going to tell you about B by drawing 4 graphs. So let's start with positive A's, meaning your y-intercept is positive, so above the y-axis. Exponential functions look like J's or backwards J's. Okay, in both of these cases, we have positive A's. Let me zoom in. Sorry, I know I'm kind of messy here. Now, what are the B's doing in these two cases? In this case, B is greater than 1. And we are increasing. Not rate of change, okay? Just the graph is increasing, rising left to right. In this one, B is less than 1, and the graph is decreasing, falling left to right. In both of those situations, we are concave up, right? Which means the rate of change is what? Increasing. Unfortunate that they use the words increasing and decreasing 2 different ways in a lot of the same problems. So just talking about the graph increasing or decreasing is literally, are we rising or falling? Is the slope positive or negative? Concavity, rate of change, increasing or decreasing. So concave up, the rate of change. The slopes are increasing. Concave down, they are rate of change or decreasing. So you've got to know those 2 different things. Okay, then we have where A is negative. Could look like this or this. So negative A, right? Y-intercept is negative. Now what's going on with the B's? This is where it gets a little tricky. You always decide B by what was happening before the flip. So if I flipped this back, so when A is negative, that's just a flip, which makes the y-intercept negative. When it was flipped, it looked like this, which is B is greater than 1. But because of the flip, we are decreasing. Okay? Over here, before the flip, it was like this, which is a B that's less than 1. It's confusing. That's why we're drawing this picture. But the graph is increasing left to right. And in both of these, we are concave down, so rate of change is decreasing. Remember D, okay? I would study that. I would just know that. And last thing I'm going to say about exponential functions is in a word problem. A is your starting price or amount. Think buy a car for an easy number, $1,000. A is 1,000. B is your 1 plus or minus your R. So the car is going to appreciate by 3% every year. You would change a percent to a decimal and add it to 1. If it's depreciating by 3%, change your percent to a decimal. Always percent, R equals a percent, change the, let's write that. And if your R is negative, your R will never be negative. If you're depreciating, you subtract from 1. Right? We had a couple problems about that. Why did I go down into my log area? What? Word problem? If you did like me and wrote in this other space, just make sure you know that we're now doing logs. I'll put logs here. Sorry, I didn't mean to go down that far. Logs, we need to know our properties. Okay? Well, let's start, because I can fit it right here. To solve a log, super easy, just have to remember how to start it. You will have a log base b. We saw this just yesterday. Solve a log, and like, oh wait, I forgot how to do it. If you just remember that you rewrite it in its other form and then solve. So that would be b to the x equals m, and then you just solve for the rest of the problem. Okay? We saw that yesterday in FRQ4. And the properties, I think we know these pretty well. Don't forget, addition and multiplication go together. Right. Subtraction and division go together. Oh, so sorry, I'm having to squeeze this. Had to put those math jokes on there that you don't appreciate. And then the power property. Remember, the number in front, you can write as an exponent you can write in front, you can toggle back and forth. Trig, we wrote a lot about trig, but I want to remind you of the order for sine and cosine graphs. Sine is middle, up, middle, down, middle. Cosine is up, middle, down, middle, up. And if there's a flip, your middles stay the same and your ups and your downs switch places. And there's a few formulas that go specifically with the graph, so I wanted to put them here. Remember, period is 2 pi divided by b, but in a word problem, it's time over cycles. B is 2 pi divided by period. And to divide your x-axis, it's period divided by what number? 4. That's for FRQ3. You had to space it out. You find your period, divide it by 4, and that's how far apart they are. Polar points are r, theta. R is just Pythagorean theorem. Remember, you're usually given some kind of a ordered pair. You draw that triangle in whatever quadrant, and then to find r, it's just the hypotenuse. And theta, you find by doing y over x. Don't forget, if r is negative, you shoot through the origin. If theta is negative, you cross x-axis. You've learned a lot. We're almost there. Remember, linear, quadratic, exponential, log. We've seen a lot of multiple choice questions like that. It could be an FRQ 1C instead of the inverse thing we did on the other page. So I'm going to break it down for you very easy. Linear, quadratic, exponential, and log. Okay? These three have the same starting sentence. Okay? Linear, quadratic, and exponential all start with over consecutive equal length input values. That would be the same sentence for linear, quadratic, and exponential. Guess what? It's also a sentence in log. The only word that changes is output. So I'm going to go ahead and write it. It doesn't matter which sentence you write first. I'm abbreviating right now. Over consecutive equal length output values. Okay? So all four of them have a very similar sentence. What comes next is different for all of them, but not too bad, okay? For linear, you would say output values increase or decrease, whichever one, at a constant rate. Guys, that's just saying that the slope is the same. Your rate of change as you go through a linear, no matter what 2 points you pick, you're always going to get the same number. For quadratic, your second sentence would be the change in the rate of change is constant. It's like second differences. I know it's a lot. We're almost done. Exponential output values are proportional. Proportional means you're multiplying. As you go through the chart, you're multiplying by something. Output values are proportional. Remember, logs and exponentials are just flips of each other. So for log, now remember we already talked about outputs. Input values are proportional. That's it. Other random things I didn't know where to put or couldn't fit. For example, quadrant 1 of the unit circle. Do you need to write it? I don't know. Is that something you need to study? So your denominators of, 6, 3, and 4, if you want to put those there. Oh, sorry. Thank you. So quadrant 1, if you want to leave yourself some space and put that there. Do you want to put all students take calculus? Do you want to put your quadrantal stuff there? Don't forget geometric sequences. A lot of times you're given 2 ordered pairs, and then you're asked to find, like, if you know this ordered pair, you know this ordered pair, they'll just give you, like, the x of another one, find y. You go into stat, enter, but you have to know what type of model they are. They are always exponential. So just remember, geometric sequences are exponential functions. They look like a J or a backwards J. And I think this is my last thing to tell you. Don't forget intersection. If you're asked to find the intersection without a calculator, like with a calculator, you just put them in y1, y2, and use intersection. But without a calculator, you set the equations equal to each other and solve. Of course, you can add anything else you want. I'm going to put the sum and difference formulas up in case you want to write them down. You saw in some of our practice exams, you did need to know them. And even though it looks like a lot, I want to remind you that when we did the whole test and lessons and everything with plus and minus, you guys did understand them. You just have to remember the little tricks I taught you. Remember, sine is social and cosine isn't. Alpha and beta are always in that order. Sine starts with S. Like same, you keep the same sign in the middle. Cosine, change the sign in the middle. So I think once you write those down, they'll come back to your brain. If you don't need to write them down, don't. You want to add anything else? Go ahead. Yeah. We haven't seen any double angle formulas for cosine in any of our practice. Maybe you want to know one of them. Remember, you could use any of the three. Maybe know one of them. You could kind of remember it by, it's almost like a Pythagorean identity, but with a minus in between, right? Because Pythagorean identity is cosine squared x plus sine squared x equals 1. So you could kind of remember cosine by it has a minus in between and we don't put the 1 on there. I don't know. I feel like they don't ask us about that one because there's 3 of them. We definitely keep seeing the double angle formula for sine now. Okay? So save this, use it, make sure you know everything on it. If you're here on Monday, I'll be happy to go over any of those things with you. Any last minute questions on any of the FRQs, multiple choice, that's it. We are done until Tuesday, the test. And you guys got this.